Relationships among remote object, stub, and skeleton classes in Java remote method invocation. Here you can see the relationship among remote object, stub, and skeleton classes. Defining remote RMI object involves specifying a remote interface for the object, but then providing class that implements this interface. The remote interface and the implementation class are then used by RMI to generate the client stub and server skeleton for your remote object. The communication between local objects and remote objects is handled using these client stubs and server skeletons. Relationship among stubs and skeleton and object that use them are shown in this figure. When a client gets a reference to a remote object, details on how this reference is obtained we discuss later, and then calls methods on this object reference. There needs to be a way for the method request to get transmitted back to the actual object on the remote server, and for the results of the method call to get transmitted back to the client. This is what the generated stub and skeleton classes are for. They act as a communication link between client and your exported remote object, making it seem to the client that object actually exists within Java. Within its Java VM. The RMI compiler, RMIC, automatically generates this stub and skeleton classes for you based on the remote interface and implementation class you provide. RMIC generates stub and skeleton classes that implements remote interface and act as go between the client application and the actual server object. The client stub class, the compiler generates an implementation of each remote method that simply packages up, marshals the method arguments and transmit them to the server. For the server skeleton class, the RMI compiler generates another set of implementation of remote methods. Remote method call, unpackage them and make the corresponding method call on object implementation. Whenever the method call generates a return data or an exception, the results are packaged and transmitted back to the remote client. The client stub method, which is still executing at this point, unpackages the result and delivers them to the client as the result of its remote method call. So the first step of creating your remote object is define the remote interface for the types of objects you need to use in the distributed object context. This isn't much different from defining public interfaces in a non-distributed application, with the following exceptions. First point, every object you want to distribute using RMI has to directly or indirectly extend an interface that extend java.rmi.remote interface. Every method in the remote interface has to declare that it throws java.rmi.remote exception or one of the parent classes of remote exception. Note that prior to Java 1.2, the RMI specification required that every method on a remote interface had to throw remote exception specifically. In Java 1.2, this has been loosened to allow any superclass of remote exception. Reason for this change is to make it easier to define generic interfaces that support both local and remote objects. RMI imposes the first requirement to allow it to differentiate quickly between objects that are enabled for remote distribution and those that are not. As we have already seen during a remote method invocation, the RMI runtime needs to be able to determine whether each argument to the remote method is a remote object or not. The remote interface, which is simply a tag interface that marks remote objects, make it easy to perform this check. The second requirement is needed to deal with errors that can happen during remote session. When a client makes a method call on a remote object, a number of errors can occur, preventing a remote method call from completing. These may include client-side errors. An argument can't be marshaled. Errors during the transport of data between client and server. For example, network connection is dropped. And errors on the server side. For example, method throws a local exception that needs to be sent back to the remote caller. The remote exception class is used by RMI as a base exception class for any different types of problems that might occur during remote method call. Any method you declare on a remote interface is assumed to be remotely callable, so every method has to declare that it might throw a remote exception or one of its parent interfaces. Here you can see this is step 1, define remote interfaces. Step 2, define server implementations. Step 3, generate stubs and skeleton using RMIC. Here you can see stub and skeleton are connected to remote interface, and here you can see the inheritance lines. Here implementation of remote interface is connected to remote interface. Here you can see the inheritance line, and here implementation of remote interface is connected to stub and skeleton class. Here you can see generated by RMC line arrow. Here implementation of remote interface is connected to remote object implementations. Here you can see instances arrow. Here stub class is connected to stub object, and you can see here instances arrow. Here skeleton class is connected to skeleton object. Here you can see instances arrow. And here client object interacts with stub object. Here skeleton object interacts with remote object implementation. Here you can see communication arrows in both way. Here also. Here the remote interface and implementation of interface, implementation of remote interface are interfaces or classes written by you. Here the stub class and skeleton class are interfaces or classes generated from RMIC. Here client objects and remote object implementations are objects created by you, and here stub object and skeleton objects are objects created by RMI. Now this is the end of my presentation. Thank you very much for watching it.